extremely significant results, all right? Some people will do this, but you may think like if you end up with a p-value of 0.0001, that it should be more statistically significant than p0.04. However, most statisticians would argue with you about that and say that's technically not quite accurate. However, others are not so rigid. They prefer to refer to some results as being very significant or extremely significant. And they'll use these asterisks, like 1 for p less than 0.05, 2 for p less than 0.01, 3 for less than 0.001, okay? So you will see this variation in the literature, in scientific papers. You'll see these asterisks. Just look carefully at the figure, the legend, what the author is writing about. Look at the p-value, look at the standard deviation, look at the means, try and think about it, okay? And you'll see where they're coming from, what sort of philosophy they ascribe to. All right, I have 2 slides left for those of you wanting to get to Netflix or whatever maybe you're doing tonight, maybe other homework. Would be great. I know my graduate advisors in graduate school said if you're watching TV, they're doing something wrong. So anyway, I hope you guys are finding a life balance in life. I will say that part. So anyway, I do want to just share criticisms of p-values. And so sometimes, you know, you will find something that is biologically relevant and important, but it's statistically not significant. An example of that is frogs and population declines of amphibians, which amphibians have naturally widely varying population sizes from year to year. It's very stochastic, which just means the populations drop even when nothing's going wrong. Then you introduce climate change, or you introduce chytrid fungus or something, and you want to see if there's a decline. Well, you might see a decline, but because there's so much variation in their population, it may not be easy to show a statistically significant decline, but it's still biologically relevant. So I wanted to make that point for you guys. You might also find something that's statistically significant, but biologically irrelevant. Like if you measure trees in one area and you take thousands of data points and on average they're 1 centimeter taller than trees on the other side, well, maybe that doesn't even matter that much, right? It may be biologically irrelevant, but statistically significant. So let's not confuse these two, okay? P-values can lead to dichotomania. And there's an article here that I have a hyperlink. I guess you guys can't click on it, but I'll share after this. It's a great article in Nature criticizing p-values. And thanks to Sarah Ray, who would put this in the registration comments for me to think about, to share with you all. Thinking of dichotomous thinking, just yes or no, it's either significant or not. That's not really the way the world works, right? In reality, there's going to be some support for different hypotheses, and you might have slightly more support than others, but it's still valid. It's not a black and white world. And so maybe we shouldn't, as scientists, be only subscribing to that way of testing hypotheses and ideas. Take-home messages, please. I know I already said this. Always report your measures of central tendency and dispersion. Now I'll tell you, some of you, if you wanted more advanced stats in this lecture, I'm sorry again. I know I've said that a bunch of times, but honestly, if you're doing means and medians and dispersion and how much things are changing, that is a huge part of explaining the data you have, right? Because there are these problems with p-values, all right? And so showing your raw data is really important. Being transparent in your data, showing it and so that others can verify your results. So as you collect data, take copious notes and really stay on top of that as well.